So welcome to everyone to this 1 hour nice and fast webinar on an introduction to decarbonisation technologies. My name is Jared Leake and I'm the CEO for the Australian Alliance for Energy Productivity, or A2EP as we're better known as. I'd like to start this session with an acknowledgement to country. So on behalf of all the presenters and A2EP, I'd like to acknowledge the traditional owners, custodians rather, of their country throughout Australia and their connections to land, sea and community. And I'd like to pay our respects to their elders. If you'd like to do something similar and acknowledge the traditional custodians of the land that you're in, feel free to type that into the chat. This webinar is brought to you today by our fabulous members. We're a non-for-profit organisation and supported by these wonderful members who support our vision to improve Australia's energy productivity. So I'd like to thank our members for allowing us to and supporting us to put on this webinar today. We've got a couple of speakers here today and hopefully they'll come off their camera, have their cameras on, you're about to see them now. I'll do a brief introduction and we'll get going into the agenda. Joining me today is Alan Pears, who is a Senior Industry Fellow from RMIT and the Innovation Lead within A2EP. For those of you that worked with A2EP past, you'll see that Alan is always there with in the background, either helping us or in the foreground and presenting. So it's my great pleasure to be joined here today by Alan Pears. Also joining me as well is Professor Andrea Trianni from UTS in the University School of Mechanical and Mechatronic Engineering. Andrea has a fabulous history of working with businesses and making them understand energy and energy productivity. And certainly has a love of business models. If we were talking about business models today, we'd have Andrea Trianni talking for quite some time. But great to be joined by you as well, Andrea. And I'll introduce these speakers and we'll get started with their presentations and the discussion very shortly. So this is the agenda we're going to work through today, and we'll start off with just some facts and figures and some concepts for you to understand. We're going to go look at a mindset and a toolbox for thinking about decarbonisation technologies. And we're going to spend a bit of time today on data and the value of data, because it sort of all starts there. And anyone who's worked within the energy space and looking at energy productivity improvements nearly always find themselves coming back to saying some more data here would be good. So we're going to put a little bit of a few stories to you today about that value of the data. So this webinar is actually a lead-in to a training course that we're running, and that's kicking off on the 7th of September in Sydney and the 12th of September in Melbourne. And so this is could be seen as a little bit of a teaser or introduction to that training. In that training, we're going to be it's a whole day training where we'll be going deep into the learnings and the technologies. So today is something a bit of a teaser. We're going to keep it high level and just try and give you the main points and give you that basic understanding, which could lead yourself to further training and further reading. So to get started today, I thought let's get going with a few figures and a few concepts. And with that, I've got Alan Pears to introduce a few ideas to us and a little bit of framing so we're on the same page here for what we're talking about. Alan, are you there?
Yes, I'm here. So thanks, Jared. And indeed, I guess one of the reasons why many people are on this call is because they're very interested in decarbonisation, and that means eventually achieving carbon neutral or zero net emissions or other things. And it actually means accelerating our emission reductions as fast as we can to limit climate change and global heating. So the broad approach for a business or a household is, of course, you start with your emissions. And the aim is to reduce them by a variety of activities, and we'll talk about some of those in practical terms. Then you'll still have some emissions, and that's where you look at purchasing carbon offsets of various kinds to achieve your net zero outcome. And the government's Climate Active website, which is listed here, has quite a lot of good resources to help you in that area. And of course, our workshops will too. Next, thanks. Just to set the Australian scene a bit, here's Australia's greenhouse emissions since the Kyoto base year of 1990, you can see that, in fact, all of our emissions apart from the land clearing have actually gone up since 1990, although recently electricity's gone down. It's also important that if you include all of the forms of electricity, gas, fossil fuels and transport, and fugitive emissions from energy, energy is over 80% of Australia's carbon emissions. And in a way, you could also say, well, in agriculture, agriculture offers us quite an opportunity for bioenergy and for emission reduction, which are very important as well. So that's just to give a bit of a picture of why we're going to talk a fair bit about energy today. To get an idea of what we need to do globally, this is the scenario produced recently by the International Renewable Energy Organization, IRENA, and you can see their basic thinking is about a quarter of the emission reduction in energy from today's level of 37 gigatons will come from renewables, about a quarter from energy efficiency, and about 20% from electrification, which itself is often really energy efficiency. And then there'll be a range of alternative fuels and carbon storage and so on. So the top one there, BECCS, is about bioenergy being used and with carbon capture and storage to achieve emission reduction. I'll pass on to you then, Jared.
Yeah, so not only IRENA, but International Energy Agency, also doing various studies and maps of how to get to net zero. And they've got a very nice report put out, I think it was May last year, called A Roadmap for the Global Energy Sector. And I've just extracted one major a little table they have there, and you can see there on that right hand side just how often just how energy efficiency and hydrogen, electrification, bioenergy, wind, solar and others fits in to get to that net zero position. And so that sort of summarizes the technologies and the things that we'll certainly be talking about. On the left-hand side, though, there's a little graph there I thought would bring in that often when you think about technologies, you're thinking about hardware, but it's the softer things as well. And the key point from that bottom left graph, when you see all this emission reduction potential there split up between transport, building and industry, is that this is about behaviours. This is what can be achieved with behavioural change. Put simply, that's turning off a light switch when you're leaving a room type thing, but on an industrial scale.
Thanks, Jared. One of the key elements of trying to reduce your emissions is that you have to think about three types of carbon emissions when you're producing your carbon footprint. So these are scope 1, scope 2 and scope 3. And lots of people find these difficult to follow. So we've tried to take a pie chart of household related emissions to illustrate this. So the scope 1 emissions are from the direct combustion on your site with gas and petrol and things like that, but also other emissions on site such as process emissions if it's industry, or refrigerant leakage and things like that. Scope 2 emissions are your purchased, from your purchased energy. In most cases, that will be electricity production, but you can also have, you can buy in heat that's being produced with emissions off your site and so on. Then scope 3 emissions are the interesting ones. These are the ones that are related to the inputs to your business or your household, and also the services that you might be using that you don't really control, such as buying food or clothing or construction materials in your building. And so you can see here, it's quite interesting that for households, this is a fairly old study, but it still holds up fairly well. Only about 1/3 of the emissions are scope 1 and 2. And 2/3 of them are actually the emissions embodied in the services and the inputs that you are drawing upon. And so one of the key things here is that we can't cut all our emissions without focusing on scope 3. So if we go to the next slide, one of the things that has recently emerged from a Commonwealth Bank of Australia report is an analysis that compares the scale of the scope 3 emissions from different industry sectors to their scope 1 and 2 emissions. And so what you can see is that most of the services sector doesn't use that much energy or produce enormous emissions itself, but the scope 3 emissions are like 20 times all of the scope 1 and 2 emissions. And this is a reason why it's important to consider scope 3. Now, of course, some people say, oh, but scope 3 emissions are really just someone else's scope 1 and 2 emissions. And while this is true, the reality is a lot of the producers of those scope 3 emissions actually aren't acting very effectively because they don't see themselves as big emitters and they're not very focused on doing something about their emissions. So we might go on to the next. Yeah, I'll leave you to it.
So Alan, I might have solar panels and I might have complete renewable electricity at home. I might have an EV, but that's only 1/3 of my emissions there. Everything else is buying all the time. Still fully embodied emissions there. So
yeah, well, we're seeing a lot of interest in the embodied emissions in the building industry with organisations like MECLA starting to really crank up from the consumer end to put pressure on the supply chains.
That's the one. Good action there. So let's talk a little bit about the technologies now, and then we'll talk a bit about a mindset which helps with this sort of change. If I just mention a couple of the big technologies, and again, when we do a training program, we'll dive into these in a bit more detail. But if I right in the middle of there, I've got solar, wind and batteries. As you may have heard, the solar panels giving us the cheapest electricity in the history of humankind. But when combined with wind and batteries, you know, there's our foundation. And with the federal government in Australia committing to this 83% reduction in carbon emissions from electricity, or 43% overall by 2030, you know, this is that main technology that's going to deliver that. But also you've got options from bioenergy, and that can be using things like sawdust and what have you, and ag waste, and either burning that directly or putting that through an anaerobic digester or other treatment method to get some biogas or biomethane out of that. The other one flowing on from the solar, wind and batteries is that electrification and decarbonised options there. And of course, hydrogen, plenty of talk about hydrogen and the opportunities there. And then generally electrification of, say, of process heating. The little shiny silver one, that's a heat pump there, a nice looking heat pump. And of course, things like electric vehicles as well. Also have to mention what's behind me there. Solar thermal. There's lots of other technologies that we could go through. We're not going to go through them in too much detail, certainly not today, like a geothermal, but that would be covered in our training program as well. In terms of a mindset of how to think about a business and industry to decarbonise, we think the coming from an energy productivity type mindset is the right way to go. Certainly, energy efficiency, known as the first fuel, is the lowest cost to decarbonise. So if we put that into context, what does that mean? This means about getting more dollars from less energy or gigajoules and less CO2. And so that gives you a focus things like on production, yield, and getting the most value out of that services and increasing the value of services. And that's really what we're talking about here when you really want to understand the fundamentals of what you're delivering and the energy and the carbon that it emits, is really understanding this end user services and how they're delivered more efficiently. We've got a couple of examples coming up for you in just a moment as well. But that really goes through a process of defining that end user service. What are you trying to deliver? And it's never quite as simple as what you think, and we'll go through that shortly. But then implementing Internet of Things or Industry 4.0 solutions to give you real-time data and really understand the energy flows, converting that data into information for the right person at the right time, and so there can be actual action from that and insight. Eliminating inefficient practices, and finally putting value or valorizing non-energy or multiple benefits or co-benefits. Don't care which way you call it. But that is absolutely crucial to seeing any sort of decarbonisation project or energy efficiency project going ahead. Just further on that bit of a toolbox that's available to you, here is sort of 10 or so different technologies for energy efficiency. You say, yes, this is the first fuel, and in any manufacturing scenario, virtually any, I think you speak to an energy consultant, they wouldn't find a site where they can't find at least 20% of savings for energy usage by looking at the way it's being used. And that can be things like top left there, that's like a very small variable speed drive. In the middle, you're saying, let's just reduce steam leaks. You could have heat recovery or mechanical dewatering down the bottom left, or bottom right. The one bottom left is optimizing your compressed air. So this is just a few of the concepts. And again, this is something we'd dive into deeper. But there's a whole range of options there to have that energy efficiency and do that first step of decarbonising right there. So throughout the webinar today, and throughout whenever we're trying to do training and talk to people about this, we think there's nothing better than taking it back to an example at home. And we're going to keep weaving that into all of our stories today. Alan, yes, this is your oven that you upgraded at home, isn't it?
That's right. So when I went off gas, I decided I needed a much more efficient oven than the ones that are available. So a typical oven's about 2/3 of a kilowatt hour to 1.5 kilowatt hours. So the best of those are about 30% efficient. And so I thought I could do better. So I've made a super insulated, smaller oven, which is about 60% efficient. But in order to do that, I had to start to work out, well, what are the actual services that an oven provides? Well, it's obviously cooking food for two reasons, really. One is for safety, because we want to kill the bugs, and the second is for taste and enjoyment. And so these are services that go beyond just the basics of achieving a technical outcome. And in doing this, I had to understand the chemistry and the physics of roasting food. And I discovered, for example, that quite a lot of water is evaporated from the food, because food is actually, around 70% water. And that evaporation of water requires a lot of energy. Likewise, you've got to obviously heat the food and the components of the oven. And so you end up with quite a lot of energy flows. And that then leads to a situation where you can say, well, how do I reduce all of these? So I had a lightweight, super insulated oven with triple glazed door. And that means I've got a very quick startup because it's lightweight, so there's not much inertia. And I had to reschedule all my cooking times for that because it was so quick. But also, there's still a fundamental issue of there's quite a lot of hot, humid air leaving this oven, and that left me with a remaining challenge to get up from my 60% efficiency to a higher efficiency. Next slide. So I've been researching air fryers because I've discovered that many parents of young children are incredibly excited about air fryers. And again, it's really interesting to look at this because it's like, well, everyone assumed you needed a normal oven that takes 20 minutes to heat up. An air fryer heats up in about 3 or 4 minutes. It uses a combination of radiant heat, which is good for crisping, and also very high speed hot air. And of course, when you think about it, the reverse of this is that on a day with a cold wind, you lose a lot more heat from your body. Well, in this case, the very high speed hot air does a really good job of cooking the food quickly So an air fryer will typically use half as much time as a normal oven. But there are all sorts of other subtleties. For example, the crisping that occurs quickly also means that the food seals more quickly, so it evaporates less water. So you have moister food. And so the services that are provided here are not just cooking food. They are about coping with a grumpy child who wants food quickly. It's about producing food that is crunchy and tasty. And again, this is about the value of the food and the service that you're providing in delivering that food. Next. And if you look at industrial bakeries, they basically go through a lot of the similar sorts of issues. And this is a study from a PhD some time back, where they broke down all of the activities for which energy was being used. And again, the green boxes are really about, well, what are the sorts of things we might be able to do to recover energy from these activities or to reduce them? And you can see, for instance, in the middle there, that the one of the ovens that this postgraduate student looked at was a lot better insulated than another one. But you can also see that evaporating water was a really big component of the energy from this. And that's where energy recovery can be really valuable. And we've got lots of great ways now, particularly with heat pumps, to recover that energy. Another interesting example of energy recovery and the use of heat pumps is the heat pump clothes dryer. The best of these heat pump dryers are like around 10-star rated, compared with a typical dryer being about 2 to 3 stars. And what they illustrate is the fact that a heat pump has a hot side and a cold side. And so the air is heated and then it absorbs water by evaporating it. And then the energy that's in the latent heat in all of that water and the hot air is absorbed by the cold side of the heat pump, which then produces the heat to reheat the same air to keep drying. So you have a clothes dryer that doesn't put lots of water vapor into your laundry and house and condense all over the place and cause mold and all sorts of things. And again, so this is not just about the task of drying clothes, it's about drying clothes without creating more mold and condensation in your house. Next.
Brilliant, thanks, Alan. So there we go. We do have technologies, but really the end user service is where you need to start with, and understanding that and saying, what do you want to deliver? And that's really what's so important about when you come to select the different technologies that will decarbonize for you. However, yes, you understand the technologies, you've got the direction, you've got the goals. Any energy consultant, anyone working in the energy industry, always find themselves coming back to needing data. Always coming back to, if only we had more data. And we're not just talking about electricity, it's all of the utilities that you may be using. Andrea, you're someone that's lived this challenge quite a fair bit there. Tell us what.
Yeah, indeed. Good afternoon, everyone. Indeed, we can see nowadays that everyone is looking at data as an enormous opportunity to transform businesses. And for instance, we are listening every day about the opportunities within Industry 4.0 brought by Internet of Things, artificial intelligence, and other emerging technologies that deal with a huge amount of data. However, if we look at what data mean, data by themselves don't mean much, actually. Indeed, we need somehow to transform the data into valuable information. So what valuable information means? Valuable information means data which are gathered, processed, and sent to feed models, so to support decision making. So to some sense, big data analytics used in Industry 4.0 help organizations harness their data and use to identify new opportunities. And this in turn can lead to smarter business moves, more efficient operations, higher profits, and so on and so forth. So collected by sensors, interpreted with analytics, and plugged into predictive models, data can lead to information and in turn to improve awareness and decision-making. So as Jared was mentioning earlier, mapping out the energy flows becomes a crucial first step that may lead to further action, such as spotting inefficient processes, optimizing production and logistics scheduling, and also anticipating other activities within the industrial operations, such as maintenance. So therefore, what we will explore during this training is exactly how you can leverage on data to support and improve decision-making over energy productivity. So this example starts from looking at a scenario with just monthly or quarterly bills. So basically, what type of decisions can you make if you only have the basic information related to monthly and quarterly bills? It's very likely that just a few minor things outside let's say the shelter can be made, such as basic PV investment with just a guess on the return of investment. If we want to take a look inside, probably very simple stuff that doesn't cause much of a disruption in the operation, such as LEDs and lighting can be considered. But how do you know really that the saving has been made?
Absolutely, Andrea. For your solar PV, you might say, I'll take 4 or 5 times my annual electricity consumption. That's how much I'll spend. But that's just a guess, isn't it?
Yeah. So the idea is, if we move on and progress with the more data, we're translating to more information, such as submitting with daily reports, what additional decisions can be made? So here we have just a list of examples, but I think we have an example in the following with Alan, who can best explain for our daily experience, isn't it?
That's right. So, Alan, you've got some nice sub-metering. Let's bring it back to the home again, and let's see what you've been able to do just on a home basis, because I'm sure that has similarities to business as well.
Yes, so many energy retailers do actually provide significant amounts of data, particularly for households that have what are so-called smart meters that measure half-hourly data. This is the top 2 graphs are examples of data from my home. The left-hand side one shows the daily consumption, and the right-hand one shows the half-hourly consumption, with the brighter colours, like the almost white and yellow, being the times when I was using most. And so out of this you can get lots of useful information, but it's still problematic because you don't get it at the time that you are doing things. This is all a day late. But nevertheless, you can certainly see, you can think about, well, what was the weather like? Did I go away for a weekend and still use a lot of power? There are lots of things I can think about with this. And if you look at the heat map, you can see my heat pump hot water service is very consistently on, except when I went away and switched it off. And I must have had a party or something one day when I did lots of cooking in the middle of the day. There are also now lots of add-on solutions around. One example in Victoria, which is available through the Victorian government scheme for free for a lot of people, is the Power Pal, but there are other things like Watt Watches and others. And this can give you real-time data, so you can actually do experiments like switching on and off appliances and things like that to understand what's going on and to pinpoint more accurately just what are the issues that you're facing.
Absolutely, and I was showing my power pal there on screen. I was able to work out my parasitic load overnight and got it down to about 80 watts. Could not find, really had trouble finding that next 80 watts, but it certainly it has helped me at home as well. And again, these parasitic loads, they're so often so easy to remove.
And a good example here is how this fits into Scope 3, because, for example, most internet providers and NBN do not deliver you the most efficient technologies for your base load internet systems, and this is actually a really good example of a tragedy, because those organisations could be delivering us very large savings over their millions of customers.
That's right, they've got the data. And so once we've got that daily data and what have you, next one on Andrea.
Well, basically, as we may see, from just scrapping the surface, we are getting down there and trying and getting more and more information and knowledge. That's the key part. So basically, if we move on, let's say with high frequency data, the point becomes, okay, what additional decisions can you make into business if you have information like 15 minutes or within 1 hour intervals? And this is, we will see an example in a minute or so, but basically this will allow you to start relating really what happens in the business and in production with respect to the energy consumption. So if we come back to the idea of energy efficiency, indeed as a ratio between an output, which is as Alan was mentioning, a service or product, and the ratio, which are the resources, in this case, energy as an input. By having high frequency data and more information, you can better know what's happening. And this can really improve your decision making. Alan, or yeah, you want me to go?
Well, I can talk briefly about this. So this is an example from the UK, actually, where they did have high frequency monitoring of a house. And Andrea's pointed out how valuable that can be. And what you can start to see here is you can draw out the signatures of the different appliances. You can identify what was causing your peak demand. And this starts to empower you to make much better decisions about everything to do with your home. And at the same time, you can also think about, well, what quality of service am I getting from these different things that are going on? Can I get better service out of them for less energy? Do you want to add any more?
Yeah, so basically the other interesting thing here is that you can really see that different appliances have different energy profiles. So you can, by having this information, you can see what happens in reality. So the difference between having a refrigerator as really as base load with something which has a different power curve, such as the the stovetop and the oven, where you have a difference from the preheating to then the cycling. So indeed, if we make the thoughts back in terms of what would happen into businesses, this is a very simple energy profile for a very simple set of appliances that everyone basically has at home. What if we extend this knowledge to a much more complex environment as a production system?
And this really comes back to what we are often talking about with A2EP, is things like sizing of a heat pump. If I was to displace the kettle there with the hot water service, you'd see, look, it's all these spikes in demand. And that understanding those spikes in demand then allows you to then size the thermal storage correctly so that you can meet those spikes and give you that overall sizing throughout the day as well to cover the total load for the 24-hour period. So once again, high frequency data certainly empowering you for these better decisions.
Yeah, and let's say finally, if we move on to the next level, which is really having Industry 4.0 data, again, we can say what sort of additional decision and additional knowledge you can make, and this will expand beyond the boundaries of the one owns business. So because it can allow further integration with suppliers, so leading to potential value chain improvements. And also, if we look internally, improved decision-making and reporting with additional ways for allocating energy cost based on a number of different activities. So actually, if we look at a process, a business where you have multiple products with a variety of codes, realize that each of them may have different energy absorption. Basically, you are able to really best allocate the impact of energy expenses on energy costs on the product itself. So this would also allow you as a decision maker into businesses to best support the activities into the company.
Absolutely. We relate that to something like a beverage factory that might be producing some flavored milk and a soft drink at the same time. You know, the whole factory probably has an average of energy use for the liquid produced, the beverage produced, but what about for each specific product? Do you know exactly how much energy and carbon emissions for flavored milk versus a soft drink and what have you? And until you can have that clarity on that, you know, a question whether or not you could make the right decisions for decarbonisation. And Alan, here's one of our absolute favourite infographics there describing all this.
Yes, okay. Well, the Australian Alliance for Energy Productivity has been doing quite a lot of work on value chains now for, what, 5 years or so. And the difference between a value chain and a supply chain is that the value chain includes the final consumer. And this is important because when it comes down to it, you have a whole series of participants in a value chain who often don't realise that basically pretty much all the money that is spread out and shared among all of those different businesses actually comes from the end consumer and the end consumer's perception of the quality and value of the service that they are receiving. And so it's very easy for each individual business to just look at their immediate supply chain and their immediate customer. But fundamentally, if you don't do a good job in your bit of the value chain, you are costing everyone else in the value chain money, and you are potentially reducing the value of the service to the end consumer. So it's a really important thing. And this is where the digitalisation, Industry 4.0 opportunities offer enormous potential to communicate and to ensure accountability, timeliness, and a whole lot of other benefits, and also to facilitate cooperation and sharing of the benefits and costs where someone has to do something. Because again, in business, we find often one company has to make changes which benefit everyone else, but may cost them money. So we have to work out ways to deal with this. And what we're seeing is, first of all, the digitalisation systems can provide the way of doing it, but also we're looking now at increasing pressure, first of all, to reduce Scope 3 emissions, which all of this can help. Second, there's increasing interest in the circular economy, where the concept is there should be no such thing as waste, because what each business has traditionally seen as a waste has to become a valuable input to another business. And in that case, again, you need the cooperation, the accountability, and a whole range of information to allow all of you to optimize your overall outcomes. One classic example that A2EP did do was find that, for example, when refrigerated food was being transported, sometimes truck drivers would turn off the refrigeration because their KPI for their business was to save diesel fuel. the fact that this was meaning there's quite a lot of food being thrown out because it deteriorated was not their problem, apparently. So this is the kind of thing that we can overcome as we utilise Industry 4.0, digitalisation, and one of the key benefits, of course, is that you can optimise the overall energy use and carbon emissions and costs while improving productivity and business profit and enhancing the value to the end consumer. This is really where we've got to go.
Yeah, Alan, if I may comment on this, this will also reflects the relevance of waste. And so the potential for reducing waste as a way to reducing the carbon emissions, because you have to transport things that will become waste. So there's weight, it consumes fuel, and it costs a lot of money to the business. So having this opportunity to leverage on data for improved decision making can really help you decarbonize the business and the value chain.
Thanks, Andrea. Thanks, Alan. And so this gives you a picture of really how to get the best possible case for decision making of decarbonisation through that value chain. And we'd like to finish off now with basically how you can then supercharge that when it comes to a business case or putting forward some request for investment here for this. So some technologies could be needing some sensors here, as we're shown here. And this really then comes back to multiple benefits or non-energy benefits or co-benefits. And we've been mentioning them throughout, like with the heat pump dryers case, the co-benefit being that you've got less mold in the laundry there. And so we'd just like to finish with today one of the concepts that would be a large part of our training course, and talking about multiple benefits and how you can use energy productivity thinking to boost profitability and decarbonise the business. Andrea, this is a nice summary there, and yeah, we're at the pointy end now.
Yeah, indeed. The point is, why do you improve energy efficiency? You improve energy efficiency because it improves your competitiveness and your sustainability. So basically, this is an example taken from a business in the US within a major report by the International Energy Agency. They made this broad overview over multiple benefits, and actually they tried to quantify the benefits and the additional benefits, so the energy and the additional benefits stemming from improving energy efficiency. And what we can see from this very small chart is, on the one hand, we have benefits quantified in terms of 60 USD per megawatt hour generated. And the cost of these energy efficiency measures accounted for about 40. So actually, it was already interesting and valuable to do energy efficiency. However, what if you really look at the implications that energy efficiency measures and so energy productivity actions can bring into the businesses here by quantifying a number of additional benefits, such as reduce carbon emissions, in reducing line losses, improved distribution capacity, and so on and so forth. These additional benefits are in the same order of magnitude of the energy benefits. So basically, one could say, okay, we're doubling the benefits. Other reports quantify these benefits in a 2.53. So it becomes really interesting to understand what are the opportunities to improve the business brought by energy productivity. So how do you get there? Because there is a lot your business can benefit.
Fabulous. Thanks, Andrea. And so hopefully you can get a feel there for the messaging that we want to bring into a training course. When you talk about multiple benefits, this can bring in multiple parts of the organisation. There could be a marketing benefit to decarbonising and adding value to your product. There could be a maintenance benefit to say, well, if we have this more priority on energy efficiency, cleaning filters and what have you, we get a decarbonisation effect, and we might have a different maintenance outcome, a better maintenance outcome as well. So we really wanted to make sure that these technologies and the way that we're talking about this brings a lot of different people from an organisation on this journey. And that's how we've designed this training program that's being kicked off here. So in Sydney, it's on the 7th of September in the city, at UTS, and then in Melbourne on the 12th of September, being hosted at RMIT. And it's very much a course designed to relate decarbonisation to home activities, so that you can go at home and actually use it at home for your own personal benefit, but also to help you visualize and think about these options and opportunities and technologies, and better visualize them for you. So that's the intention. Is this course is high level, not too difficult. We'll go through demystifying all these acronyms that will come at you. Anyone who's first jumped into this energy space, by the time they have ESCIs, VEECs, ACCUs, and all these different terms coming at them, it can be quite a head spin. So we'll take some time to go through that and demystify those, demystify a few myths, and then run you through these technologies and how to go about it. We're not diving into detailed pathways and developing a detailed pathway for you. It's not for a course for somebody who's already been doing energy consulting for 5 years. This is for people to bring more people on the journey, more people into the knowledge of decarbonisation, and then with energy productivity as a great enabler to kick that along as well. We also have a further course that we're designing about integrated design, and that is more for engineers that have worked on this in this space for a few years, and we'll be learning, taking a lot of learnings from the likes of the great Amory Lovins and applying those learnings into new ways to do integrated design to better implement decarbonisation technologies. So that's the courses that we have planned. This is the agenda, and you'll find that on our website, and we'll send a link out to you all that's attended today, and so that you'll be able to look at and join that training. Again, it's a training for all sort of a wide group of positions there, graduate engineers, marketing, finance, communication types, HR could be really good for them to understand some of these concepts, and that help with their business partnering in the organisation as well. So really looking forward to getting a lot of people onto that training and going through this. With that, I'd see if we could see if there's any questions in the Q&A. I think we've got a couple come through there. I'll just bring them up and see where we're at, and see if one of the our speakers can present this. We've got a comment here, I think maybe more about Danfoss's research conducted with Southeast Asia. Estimates waste within the farm to fork cycle, including refrigeration processes, with this estimate annual losses of 700 million per annum by 2035, a billion. So yeah, I think that I appreciate the comment there, Daryl, and well taken. Just some feedback there. A comment there, can the IoT within transport be implemented across Southeast Asia and Africa? I certainly don't see why. Alan, you were a bit closer to the project we did with food. Did that require a very good network of 4G towers or anything?
No, well, that project was, well, there's an increasing rollout of what they're calling low power wide area networks, which can cheaply deliver small packets of data. And so that's certainly rolling out within Australia. I think once you get into developing countries, I think you may well have to use other alternatives, but we need to keep in mind that a lot of developing countries have got very good internet and very good mobile phone systems because they have jumped over the landline. And so in that context, those networks provide a very good opportunity to do a lot of the data sharing that we need, because you don't need enormous amounts of data. This is the key point. It's you can do local processing of data to convert it into useful information and insights, and you can then send a lot less data around, you know. So I think Andrea is probably better than me at these kinds of things, but that's I think we're heading in the right direction. But I think even Australia, we're really in the very early days of all of this. It's just starting.
Yeah, I totally agree in the sense that even though we can see that the future is going towards the Internet of Things, and which relies on this huge amount of data, the thing is most of the businesses are more closely towards Industry 2.0. So we are very much at the early days, and there is so much to do in terms of, you know, growing awareness, growing knowledge, growing skills, and bring things into action. So a lot of potential there indeed.
And there's a lot of potential even with this within a business. It's within one business. And I did some work for A2EP with the New South Wales government looking at compressed air in industry. And, you know, your average compressed air system is like 15 or 20% efficient if you're lucky. But once you start looking at all of the different services provided by compressed air, many of them can be replaced by much, much more efficient, much more productive electronic devices. And they can also be smart and connected, and they can actually transform business productivity. And so the report I wrote, which is on the A2EP website, really went into looking at all of these different activities and the alternatives that can transform a business, not just reduce compressed air costs.
Yeah, but you know, also on the other thing that, well, we can see, we touched on this a bit. Jared touched on this at the very beginning, was related to the behavioral changes that are in there. So on the one hand, we have the technological change that needs to come in play, but on the other hand, there is a lot of things to do in terms of changing the way the activities within the businesses are run. So the fact that you can move things across, where you really need to go and crack the point of, we have done things always in this way. So we consume because we have been always consuming this way. And that calls for a big change. So yeah, I think there is a great opportunity to make an impact here.
Wonderful. Thank you. Thank you. And it looks like there's no more questions, but we do have a few minutes if anyone wants to put something in there. In terms of the presentations themselves, we'll make this presentation available like we always do, and the recording, we'll send that out sometime next week. Anyone who joins the training will see the similarities and the passion, of course, behind energy data and understanding these services as a way to decarbonize, for sure. But yeah, we'll have these slides and everything sent out to you all next week. Gentlemen, I can't see any further questions coming through, so I think we've covered most of what we want to. I'm sure we could have spent another several hours. Yes, Alan's laughing. We did start with about 1,000 slides here, and we trimmed it down as much as we could. But we really hope that we've given you the introduction to decarbonisation technologies and how you can go on that journey yourself. So with that, I'd just like to thank Alan and Andrea for joining me this afternoon. Thank you all to those that have joined us live on the webinar. And we look forward to hearing you more, and for further webinars coming up, you can go to the A2EP website where you'll see what's coming up there, and our Innovation Exchange conference that's happening in October. You'll find more details on that as well. And again, for registering for that training, you can go to our website. Thanks very much for joining us today, and I hope you enjoy the rest of your afternoon. Thank you.